Hello everyone, I cordially welcome you all to today's video. This will be the last video of the React tutorial series. In this video, we are going to discuss on the basic app optimization techniques which can help you to write better React applications. So without any delay, let's get started. The first technique which we are going to discuss is windowing while list rendering. It is a very common scenario in React to display long lists of data. For example, if you are developing an e-commerce website for the products page which will display a list of available products, rendering will take a lot of time, which is directly proportional to the volume of data which is being sent to the front end of the application. Now if you have some re-rendering logic set up, this is going to reduce the performance even more. So what to do? Windowing comes to the rescue. Windowing means instead of fetching all of the data from server and then populating it on the DOM, we can bring a small slice of the data initially and then bring the rest chunk by chunk or slice by slice as required. For example, pagination is a great way to solve this problem. On the first load, we can bring data which are to be displayed on the first page and then bring the other data when the user navigates to the other page. Infinite scroll is also a good alternative. We display a small chunk of data initially and then can load rest data as the user scrolls down the page. The next optimization technique which we are going to discuss is use key while list rendering. A key is a special string attribute which is needed to be included while creating list of elements. If developers miss setting up the key attribute, something like this might be shown in the console. Warning: each child in a list should have a unique key prop. This is so because while rendering list in React using the map method, we are supposed to pass a prop called key, and the value of that prop is required to be unique among the list of items. Never use index of item within the list as a key. This is a serious anti-pattern that must be avoided. We have discussed about this in a separate video. I will link the video in the description. You can watch it out. Let's proceed. Lazy loading images. Images are an indispensable part of any website. If you directly embed videos using the img tag, your application performance will degrade as React will try to load all the images before rendering the UI on the DOM. For this, we need to lazily load images such that when the given element is coming within the view, then the images associated with those elements will load lazily. There are multiple libraries available in NPM which supports this. The next technique: usage immutable data structure. When writing component state logic or while using Redux for global application state, we must avoid mutating the data directly as majority of these functions are asynchronous. Rather, we must consider using callback functions such that we take in the previous state and some arguments, that is actions for Redux, and return a new state. We have a separate video for Redux setup where we have discussed about the basics of Redux, and another video where we have made a project using Redux. You can watch them out. Let's proceed. Using pure component in class components. As already discussed in the previous articles, pure components are greatly beneficial to use when we work with React state or props. In case the value of state and props have been updated with the same value, pure components don't trigger re-rendering of component. Unlike generic component class, the pure component, by suppressing unnecessary rendering, ensures better performance of the component, which leads to proper rendering optimization for the entire React app. The features of pure component are as follows. State and props are shallow compared with the previous state and props data before calling this.force update, hence optimizing the re-rendering process. Takes care of shoot component update lifecycle method implicitly. Pure components are more performance efficient than their counterpart. Okay, let's proceed. Using memo in functional components. React components are designed to be re-rendered on change of props or state data. Though in general this is the norm, but in cases it reduces the application performance. For example, for any state change in the parent component, all the child components will re-render even with the same props. This highly increases the re-render time. To avoid this, we use React Memo. React Memo is a higher order component provided by React. This wraps around the component and memos the rendered output such that for same props passed, it doesn't re-render the entire child component and reduces the last rendered result. React memo is mainly used with functional components. As for class component, we already have react.pure component, which automatically handles the should component update on its own. My motto for using pure component in class components and memo in functional components is just to optimize the re-rendering process. If props and states haven't changed, why you should re-render the child component? You can avoid this. You can only trigger rendering only when the state or the props change, and that is why pure components in class components and memos in functional components are beneficial. Let's proceed. Using prop types or interfaces in React. When you pass data from parent to child component, it is very important to check the data and the type of those data which are passed as props. If you are using reactjs, you can use prop types to validate the props. If you are using React with TypeScript, then you can use both prop types library or interface provided by TypeScript for the same purpose. The reason is when you pass any data from parent to child component, in the child component you should define the proper type of props that it wants to have. If you write something like any, what will happen even if some wrong data is passed or some data is missing, the component will try to render and this can lead to fatal results. Okay, let's proceed. Using fragments in React. Both in class and functional component, we can return a single parent div element, which is basically the root of the JSX tree for our component. In case we want to return multiple div elements, we need to wrap all the div tags with a parent div element. This not only adds up extra node to the DOM but also creates unnecessary nesting of div elements. This is so because React uses the tree-like DOM structure which is utilized for reconciliation. Reconciliation is a process by which React differentiates with one DOM tree with another in virtual DOM to check which parts or nodes to update and then do the update in real DOM tree in browser. So in case we use multiple coordinate DOM nodes with no parent root, the reconciliation algorithm would fail. So there was a video made separately for React fragments. I would request you to watch it out. But here in short I will say reconciliation algorithm is the code which makes React application fast. Basically it compares the real DOM with the virtual DOM, and when it finds the nodes which have changed, then it updates the real DOM. So it need not to write the entire DOM tree, so that saves time and improves the application performance. But if you want to have coordinate DOM nodes by having divs without any parent div tag, your reconciliation algorithm would fail. In that case, fragments come to the rescue. Advantages of using React fragments are as follows. The unnecessary div elements expands the HTML DOM, which leads to consumption of more resources by the browser. In the other hand, fragment clears out all unnecessary div elements but still acting as a wrapper for child elements. This leads to faster rendering and discounted use of memory resources. Secondly, React fragments provides better code readability than expanded div elements. The last but not the least, fragments allow the developers to return multiple JSX elements without causing any parent-child relationship issue. Suppose in an application you have some parent-child relationship in such a way you are using display flex. Now if you introduce one more div in the middle, that will entirely break the CSS you have written. But if you want to do so, you have one option in hand. You can use the fragments. Fragments not only saves you from polluting the DOM tree, but it also helps your code to be more readable and also easily debuggable. Okay? Some other important optimization techniques which you can keep in mind while writing React applications. I have just jotted down some of them here. Point number 1, using usecallback hook. When we pass method as props to child component, the child component should either be a pure component or should be wrapped by memo. Secondly, use CSS animation. Try to reduce JS-based animations as much as possible. Third, use web worker for CPU-intensive tasks. Fourth, use server-side rendering. Okay. Fifth, using gzip or deflate compression on web server. The last but not the least, throttling and debouncing event action in JavaScript or TypeScript. So if you keep this many points in your mind while writing React applications, you will find you will write a far better React app which will be not only production grade but will also be loved by the users of the application. Okay, and majority of these points have their own separate video, which I will link them in the description, and I request you to watch them out if you fail to understand any one of the points. Okay, let's proceed. I hope you found the video informative. In case you found this video useful, feel free to hit the like button and subscribe to our channel. We are going to bring more videos in future. For any queries, doubts, suggestions or feedbacks, feel free to post them in the comment section. We are going to reply. So thank you for now. See you in the next video. Bye.